Okay, fine. I'll be presenting. I'll be take the lecture. You can able to answer. Okay. Hmm? Okay, fine. Today we are going to discuss about Unit 6, Color Image Fundamentals. Up to Unit 5, we are discussing about the image processing on grayscale or black and white images. Okay, we already know that we have discussed lot of things, but it will be done only in the black and white image or it is in the form of grayscale image. But in laboratory, we will be worked in the colored images. But here we are going to discuss some details about the color image fundamentals. Before go for the image processing, you want to know what are the fundamentals in the color, how the color can be able to identify and how it can be handled in image processing. Okay, so mostly, okay, don't write, just you can listen. Normally the color is divided into two major areas. One we can call it as a full color, the another we can call it as a pseudo color processing. The full color means whenever if you seeing the TV or capturing the image, what we are seeing, we are able to capture. That is called the full color. Pseudo color means we are able to convert the grayscale image into the color image. We are forcingly or voluntarily adding a color to the image. We can call it as a pseudo color processing. So mostly we can discuss about the full color or it is a pseudo color. When the full color means what we are seeing, it is able to capture that image. Pseudo coloring means we are able to add a color to the grayscale image, not a filter. In olden days, we were able to see black and white film is there. After that, there is a color film is there. But on that color film, we are not able to get a true color. We can able to see only some colors will be highlighting. The remaining colors will be in the gray only. After that, only nowadays it is coming for the true color. True color means it is more depth and more colors in the display. We're able to see the difference. So the film is shooted by the grayscale, then they added the color that we can call it as a pseudo colors. In general, the colors is n number of colors are there, but we're not able to see in the eye. It is like a race. We can see in this atmosphere there is a n number of gases are there. We're able to feel that only we have taking oxygen, but we're not taking oxygen. We're also taking some other gases also, nitrogen gases also. It cannot be able to see in the eye. Same like that, there is number of colors which cannot be seen in our human eye. Some colors will be seen by the animals, their eye. We can able to see the difference. How the this images are you are sitting here, how I can able to see means it is simple. Whenever the light is uh, reflecting on your body, that will be reflected, then it will be converted as an image. This can be done in my eye very fastly so that I able to see the image. If somebody is sitting in the night without no light, you're not able to see anything, we can call it a black color. Is it clear? Okay. Now, what are the colors is available, visible and invisible colors? How it can be identified? So there is a scientist, Isaac Newton, Sir Isaac Newton. They take an optical prism. Prism is nothing but it is like a triangle shaped glass. They pass a white light in one end. In another end, it reflected and shows some rainbow colors. Okay, starting from ultraviolet to the infrared color. In this, all the colors will not seen by our human eye. Some colors will be seen by human eye, some colors will be seen by the uh, animals. Okay, so what are the colors we can see, how they are able to measure? For example, if you're able to hear some sound in your ear, there is some limitation will be there, minimum and maximum. If we exceed that maximum, we're not able to hear that sound. Same like that, that minimum value is lesser than value, you're not able to hear the volume. So there is some limitations for him. Same like that, while seeing the image also, there is some limitations. It can be measured in some units. Okay, so we are passing the white line, the optical prism. You are able to get some rainbow colors, starting from ultraviolet and ending with infrared. In these colors, we're not able to see all the colors in our naked eye. So, what are the colors can be seen? It can able seen only six colors in this. One, we can able to see a violet color, blue color, green color, yellow, orange, and red. It is able to see as a naked eye. Naked eyes means as a normal human eyes. These colors are able to measure in the units. If we measure the sound means it will be measured in terms of dB. If we measure the light rays in the measure of nanometers. Okay, we can call this a word called wavelength. We can measure by using a nanometers. So each nanometer means there is some values will be there. Okay, it will be starting from 300 to 1500. The 300, the wavelength 300 nanometer means it is a black color. We can call that particular color as the ultraviolet. Ultraviolet. You can go for the 1500 nano, the last. We can able to see the black color. We can call it as the infrared rays. This ultraviolet and infrared ray, we can able to see all are black color only. We are not able to see that. The infrared is nothing but I giving an example. You have the remote control in your home. There is a top of the remote. There will be a LED. If you press that, sometimes the LED will be glow or sometimes not go. But what happens? So the emitting a light source. That light source is called as a infrared. It cannot able to see in your eye. Yes, yes. That is a wavelength of 1000 to 1500. So what are the rays can able to visual means there is a spectrum of 400 to 700. That is a visible spectrum, meaning that that particular light rays can able to see in your human eye. You can able to see some colors is there that the basic colors we're able to see. Okay. Other than that, you can see the top of that. In this top of that, what or where it can be used, which light rays can be used where. Okay. If it is ultraviolet rays, we can call it as a UV rays where it can be used to destroy the insects or we can see the infections like a blue color light. Yeah, we can able to see some scanning are able to see that. Okay, that is the ultraviolet rays. Okay, this visible spectrum we can able to see that six colors. The visible spectrum we are able to see some six colors are red, green, blue, red. What we are discussing. The next is infrared ray, which cannot be seen. Other than that, there is some other rays will be there. It is called as a microwaves. It called for a TV and radio. Okay, it can be travel more long distance light rays. Okay? So now we are focusing only on the visual spectrum where the human eye is able to see some lights, that is the colors which is able to seen on the nature. We are already know that the basic color we are using is red green blue, red green blue, RGB. So what is the color band of this color? The band is nothing but the wavelength of this color. We are already studied it. The wavelength from 300 to 1500. In this 300 to 1500, only the wavelength of 400 nanometers to 700 plus nanometers are able to visual. So my question is, okay, it will be coming. My question is, in red color, what is the wavelength in nanometer? Blue color, what is the wavelength? Green color, what is the wavelength? That is a diagram. It is representing here. Okay, the wavelength is starting from 400. It's starting from 400 to 700. It is a visual wavelength. In this, if you want to see the blue color, we are able to see the wavelength of 445 nm nanometer. Same like that, if you want to see the green, actual green, 535 nanometer wavelength. The next is red, it is a wavelength of 575 nanometer. If you see the wavelength of that particular value only, it is a red color, it is a green color, it is a blue color. Otherwise, what happens? It will be changed, blurred, or sky blue, light blue, dark blue, like that. It will be changed. Okay. In between this, there is another color is also there. If it is a color between 450 to 500, we are able to see blue color. Okay, we are able to see the blue color, but in between, we are able to see the blue green. If the wavelength is increased, we go for the slight change of green shade. Here is the most important thing where there is a two types of colors, primary color and secondary color. What are the primary color? Only three colors is the primary color. What are the three primary colors? You can able to say red. Red is the, blue is the, green is the. Okay, red, green, blue. This the three colors is we can call as a primary color. Secondary color means the combination of these colors where we can call it as a secondary color. Okay, we can see all these color combined together, green, red, and white. Combined means we are able to get which color? White color. It is a secondary color. Okay, you can go for this green and red is combined means we are able to get the yellow color. Green and blue is combined means we are able to get the crayon color. Red and blue we are able to combine means we can get the magenta color. Okay, the combinations we are able to get a different colors. Okay, is it clear? Now we can see what are the primary colors. We can see yellow, crayon, magenta, it is the primary colors. Sorry, secondary colors. What is the primary colors? Red, green, blue is the primary colors. So in this we can able to see the black color. Yellow, magenta and crayon combined together we are able to get the black color. Green, red and blue combined together we can able to get the white color. So we want to see that whenever if you are increasing all the colors, you can go for the black color. When you are decreasing all the colors, it go for the white color. If you are increasing all the colors, go for the black. If you are decreasing all the colors, it go back to the white color. That is the meaning. Is it clear? Now, we already know that we knows only the primary color and secondary color. The primary color we can call it as the red, green, blue. What is the secondary color? We can call it as the CMY, cyan, magenta, and yellow. So here there is a three types of color models. Here we are going to discuss about the three types of color models. These three types of color models can be used in different areas or different situations. Okay, RGB color model is mostly used for capturing any image or image processing. Same like that CMY, the secondary colors are can be used for identifying some image processing. The third is HIS color model is mostly used to edit the images. We can see one by one what is this. Okay, in I already told that the color models in nowadays are you oriented either hardware or applications. So we are able to know that if you want a clear uh, animation movies to be run, or you want to play some n number of games, we require a graphics card. So the color can be generated or processed by using a hardware. There is another thing is that normally if you take the system, I'm not using the game, so that I'm able to use some operating system to find the color models. So there is a two way, hardware and software. Mostly all the colors are generated and managed only by the hardware. That's why if you go for the gamings or high-end resolution videos or images, you should have the graphics card. Then only they're able to produce that depth of the color. So here we are able to see the three models: RGB model, CMY and CMYK color model. K stands for black. I am explaining one by one. The third model is HIS color model. So what is meant by the RGB color model? You can see this diagram. Okay. Till now we are explaining that red, green, blue, but here we are representing in the form of the chart or graph. Okay, it is a three-axis graph because it is a three parameters: red, green, and blue. Here you are able to see red. R stands for red color, G stands for green color, B stands for blue color. Whenever it will be named in the terms of R is ranking one, first order, green is second order, blue is red order. That is third order. Okay. So I am representing the red means I want to use within bracket 1 comma 0 comma 0, meaning that it representing only the red color because the red is the indexing first. For green color, it will be representing as 0, comma 1, comma 0. Green indexing is second. Go for the blue color, we can see 0, comma 0, comma 1 because the blue is indexing as the third. So 0, comma 0, comma 1. If I represented that anywhere else in 0, comma 1, comma 0 means it representing the green color. Okay. Right. This are three lines we are discussing. Okay, we can this the middle point we can call, we can able to see the middle point. In this we can return as the black. Why? The combination of the three colors will be produce the black color. Okay, you can able to see this red, green, and blue combined together to give the color as a black color. Okay, so the center point of the diagram representing the black color. Okay. The another secondary colors also will be representing, can able to see magenta. It is between the red and blue color. White color, it will be in between the red and crayon where you're able to see moving. Wherever the grayscale is increasing, the color we are going to increase, we go for the white color. That is entirely should become white. Okay. Then there is another call in between red and green. We can call it as a yellow color. So this cube will be representing the RGB color model. What we are seeing here, we are able to see in the terms of a color image. We are able to see this cube, it's a color. We can see this point, it is a red color. You can see this point, it is a yellow color. You can see this point is a crayon. This point you can able to see a black color, sorry, white color. The black will not able to see because the two-dimensional diagram. Three-dimensional able to see the black color. Okay, you can see this part we can call it as a green color. The top we can able to see the blue color. In this we can able to see the magenta. So in this way, the color model cube will be representing. In this way, the color model cube will be representing. Is it clear how the color model is representing in the terms of the diagrammatic representation? The same thing is happened in the previous class. No, this class only happening. Is it clear how the color model will be there? The graphical method is a graph method, as well as you can go for the color model also. Okay, I'll check for the online classes. Now, how the color can be done? We already know that. The combination of the red, green, blue, we are able to get the colors. Okay, so the image, the red, green, and blue is separated and combined together to get the RGB color. Okay, if you remove any one color, how it can be happen? We can see here. There is a three images representing the values from 0 to 255. Why it is a 0 to 255? Pixel intensity value. It will be representing from 0 to 255 only. So if the R value is 0, if the R value is equal to 0, in this diagram there is no red color. If the G is equal to 0, in this diagram there is no green color. If B is equal to 0, there is no blue color. If we combine all these colors together, we can able to give some true colors. So this is called the RGB color model. Nowadays, in a system, in a online browser or image processing or what are the images, what you are seeing in your mobile, we can call it as a safe web color or safe browser color. The thing is, what we are seeing, it is a true color where it will be a combination of 256. In this 256, they are using 216 colors. The 40 color is reserved. How it can be done means the colors will be represented in the form of values, hexadecimal value. Each color is having a hexadecimal value. We can able to see this color palette. This color palette, each color will be representing a value in the form of hexadecimal. Do you work with any web design or you are working with HTML tags? Yes. Okay. In this website, you want to give the color. We can able to give the color as a word or able to give as the code. That is the hexadecimal will be representing the hash. Yes or no? Yeah, the same thing. So the colors will be representing the form of there is a 256 colors are there. In this, we are able to see 216 colors. The colors will be representing by using the hexadecimal values. All the values 0, what is the color? All the values F, what is the color? Simple. It will be size if it is a 2 digit. If we go for millions of colors, the digits will be increasing. 4 digits or 6 digits. Okay. This is about the red, green, blue color model. The next we are going to discuss about CMY and CM. So what is a CMY? We are already know that it is a secondary color. So from secondary color, how we can able to get the primary color? By doing a simple operation. -1. 1 minus RGB, we are able to get the secondary color. So there is original color, primary color. You want to find the secondary color. You want to perform 1 minus primary color. We can able to see how we can able to minus this RGB. We are already know that what are the image we are representing in the image processing tool. It will be converted into matrix. Will be converted into the matrix. So image is automatically converted into the numeric values. So if it is a colored image, there is a three matrix of that: red color separately, green color separately, blue color separately. If you separately, red separately, 1 minus red color, 1 minus green color, 1 minus blue color means you are able to get the image in the form of secondary colored image. In the form of secondary colored image. That is the thing we are able to see in the formula. If you want to get the secondary color, it is very simple. By minusing 1 minus the primary color, we are able to get the secondary color. Because, because we this diagram simply representing there is a matrix 111 minus matrix RGB. But you want to think that whenever the image processing is representing, it will represent the form of matrix format. So image is converted in the matrix. Once the matrix is converted, it will be converted each and every pixel as an intensity value. The range will be 0 to 250. So even though we are using CMY color, that is a secondary color where we are able to see in the olden films. So in very old film, only white color, black and white image is there. Nowadays, it is a true color image. In between, there is a colored pictures or videos or the cinemas where you're able to see only fixed number of colors are there. So that color we're not able to get a true color. So the secondary colors are not able to give a true color image. To want to give a true colored image, the secondary color is added with the black color. All the secondary color is added with the black color so that you are able to get a true color. Okay. It can be seen by using a printer. In inject color printer, previously there is a three colors, red, green, blue will be available. Okay, the combination this they are going for the color print. Nowadays the printer is coming with CMYK model where cyan color, magenta color, yellow color. In between this, there is an extra color called black. By combining this, we are able to produce a color image. This is a model where it is used in the printers. Is it clear? CMY, why we are adding the black color. The black will be representing by case symbol. Okay. The next is HIS color model. What is meant by HIS color model? H stands for hue, saturation, and intensity. These three words are able to related, are able to check, are able to recall where these three words is can be studied other than the image processing. Hue, saturation, intensity are able to recall. Everybody is having a laptop. Yes. You go for the display. Okay. Display option. In this display option, there is the two things. We can able to change the gamma level, intensity level, or you want to change the there is one arrow mark will be there. We are able to move that. We can able to change the color. Here the color will be changing like how we can see. Okay. I'll be showing in the next lecture how this gamma will be working, hues will be working. Okay? So from this, we are completing today's lecture. So we
So,
have completed 20 to 25 percentage of the lecture portion.
sir, excuse me, sir. Hello, hello, sir.
Yes.
Sir, what is a digital vibrance?
Pardon me?
Digital vibrance.
Digital.
Vibrance. Can you check the chat box? I put it there.
Okay, just a second. I'll be check now. What is the digital vibrance? I'll be check. Okay, I'll be check and let you know tomorrow.
Yes, sir.
Yeah, fine, fine. Okay, from this we are closing the session. If you have the mobile, you can drop your enrollment number. Okay, dear student, just you can drop your enrollment number for attendance. I hope that you are able to understand somehow what is the color model. 4, 5, 6. In midterm one, 1, 2, 3. Here, 4, 5, 6. I'll be sure some previously what I shared some important question. No, same like that I will be sure. Okay, try to write a related answer in your answers. Okay, then only you're able to get the mark. Okay, kindly share the enrollment number for attendance and leave the class. Ma'am, good morning, ma'am. Ma'am, good morning. It is audible, ma'am. Okay, you are also from 5TC2. Both of them 5TC2.